Hello everyone. In this section, we shall implement a project. This is the paper by Fadi Sahib Hassan and Mariam Amir Safo. This paper is on FPGA hardware co-simulation of image encryption using stream cipher based on chaotic maps. So in this paper, the main motto is to encrypt an image using chaotic maps and finally simulate the model in FPGA platform. So we should try to implement this paper in this section. Our main motto is to encrypt an image and develop an image encryption model using System Generator and then simulate in Simulink. We shall restrict ourselves to simulate the model on Simulink and then verify the outputs. So I am just giving the main motto of this paper. The overview is that there are basically three chaotic maps: logistic, lossy, and tent map. These two persons proposed two new systems, XOR and Cascade, using these three fundamental maps. They implemented the model on Simulink and finally they implemented this model in the FPGA platform. They used this Xilinx board for simulating the model. So we shall simulate in the Simulink and then verify the outputs. After the image encryption is completed, there are some tools to verify the image encryption standards. Those are NIST tools and NPCR and USCA analysis, key space analysis, and histogram analysis, and so on. So these analyses will give an idea how much better the encryption is and how much you need to increase the encryption standard to save from the cryptanalysis. So now I am giving an overview what is chaos, what is chaotic cryptology, and I will explain the three fundamental maps and give an overview on the image encryption model. Then we should implement the whole model in the Simulink using System Generator. So chaotic cryptology. Cryptology is the study of cryptography and cryptanalysis. Cryptography means it is encryption and cryptanalysis is the reverse process, which is the decryption. So what is chaotic cryptography? Chaotic cryptography is application of mathematical chaos theory to the practice of cryptography. In mathematics, we have a concept called chaotic theory. So by implementing the chaotic theory to the cryptography, we can increase the encryption standards and thereby reducing the cryptanalysis attacks. So in order to resist the choice of plaintext and non-plaintext attacks, the key is to be generated based on plaintext messages. So what happens in the encryption method is that a key is generated is used to encrypt every plaintext message and then a cipher message is produced. But the drawback is that the same key is used for every plaintext message. So this is somewhat a clue for the cryptanalyzer so that he can decrypt the cipher image. But if we generate a key which is a function of the plaintext image, then we can increase the encryption standard, so thereby reducing the probability of attack. So in chaos theory, we have one-dimensional, two-dimensional, higher dimensional chaotic maps. So using higher dimensional chaotic maps will increase the standard of encryption. So what are the chaotic maps? So before going into chaotic maps, I will explain what is chaos. Chaos is the disorder or the randomness which is present in the patterns of the state variable. The properties are: it must be sensitive to initial conditions and it must exhibit non-periodicity. For chaotic maps, there are mainly two parameters. One is a controlling parameter and another is a state variable. So based on these two parameters, the chaos of a function will be determined. So a chaotic map is a function that exhibits some sort of chaotic behavior. So in time domain, these are classified as continuous and discrete, whereas in space domain, these are classified as real and complex. The three chaotic maps implemented here are logistic, lossy, and tent map. These are discrete in time and real in space. Discrete in time implies the time factor is discrete and is represented by n equal to 0, 1, 2, 3. That is discrete time steps. In addition, two hybrid maps are implemented, XOR and cascade maps. So we shall see how the maps are implemented. So development of the model. There are three stages in the model. The first stage is that the plaintext data is converted into fixed point representation. In our project, the data is the image. So the plaintext image, every pixel of the image is converted into fixed point representation. And in the second stage, the fixed point chaotic map pseudo random generator is implemented. That is, the output from the chaotic map is converted into fixed point representation, and then these outputs are XORed in the stage 3, and then the cipher bits are produced. These cipher bits are again converted into unsigned 8 or unsigned 16 representation as of in the image format, and then the encrypted image is produced. So in the next video, I will explain what are the logistic, lossy, tent, XOR and cascade map, and we shall implement these three maps in Xilinx using system generator, and finally we shall verify the encryption standards of the encrypted images. Thank you.